In this video, we're going to recreate the Pluribus intro in Blender using mainly geometry nodes. If you'd rather just download the project files, I will link that in the description. I'll just put it on my Patreon. But if you want to just learn how to make it yourself, I'll take you through that step by step right now. We can go ahead and delete these for now, and let's go over to the video editing tab, and let's find our reference video. This is the actual title sequence from the show. It's always good to have this here just so we can check it out if we need it. Now let's go back to the layout tab and let's set our frame rate to 30 FPS. I'm not 100% sure what the FPS is of the title sequence. This one I downloaded from YouTube, so I think the FPS might have changed, but either way 30 FPS will be smoother, so I think we want that. And I know that the FPS of the show is 30. So next we're going to import the SVG of the logo. So go to where you downloaded the logo, import that, and I'm going to join them all as one object, and we're going to separate them back out later. But first I want to center the origin point to the center of the object and center it in our world space. And it's still not perfectly centered, so let me hit A to select everything and move it over slightly, and that looks about right. Next I'm going to scale this by 6.5. No particular reason, it's just when I was experimenting with this off camera and I was setting up all the nodes, this is the size that I went with, so I want to keep it consistent. And after we've done that, I'm going to apply the scale. So you'll see it was 6.5, but now after I apply the scale, it is 1. Alright, next we can convert this to a mesh, and we will go to the object data tab right here, go down to the remesh tab, and we're going to remesh this by 0.01 voxel size. And you'll see there's a little bit of a, I guess, blockiness on the edges, but that's totally fine for what we need to do. We can remove this material, we're not going to use it. Alright, next I'm going to name this Pluribus Geo, name that collection, and name this object Pluribus Geo 1, actually just like that. And then I'm going to separate each object to be their own thing. Let's separate this one, and I'm going to do each one progressively just so they're in order. And next let's set their origin again to their own centers. Alright, now we have each text as their own object, and we're going to give them a geometry node setup. So I went over to the geometry node tab and add a geometry node, and we're going to switch out this tab for the video sequencer and find the scene where you have the video reference, and then move this to preview. And now when you go forward in the timeline, you can see the reference video there. So I'm just going to keep it like that. So let's create a new geometry node. Let's name this Pluribus text and make sure you save. You can select all your letters, and if you have the copy attributes add-on, which looks like this, then you can just press Ctrl+C and copy selected custom properties, or wait, not selected custom properties, copy selected modifiers, and choose geometry nodes. And now they will all have the same geometry node, which is the Pluribus text we just created. So here is our nodes, and we're going to start off with creating that fingerprint effect. So let's go ahead and change this mesh to points. See what we have. So now if you look closely, each of those vertices turn into a point, and now we just have to delete all the ones that we don't want and leave ourselves a fingerprint shape. So we're going to do that by deleting geometry and plugging that in. Now if we plug it in now, it deletes everything. So we want to choose what we're deleting with a wave texture, and we want our texture to be rings rather than bands. Choose our z-axis, and let's adjust the contrast with a color ramp node and put it in there. And if we move this up a little, you'll see that we're starting to get a fingerprint shape right here. And let's continue to adjust the contrast like so. Let's bring our scale down to 2.7, and the center of our fingerprint is the center of the object right now. So to change that, we need a position node combined with a vector add node. Vector add node. And this will need to be moved over to the left. And that's pretty much it for the fingerprint effect. But if you zoom in, you'll see that there are a ton of vertices within this line. So the next thing I want to do is delete a lot of these repetitive unnecessary dots. So I'm going to duplicate this delete geometry thing, and it deletes everything, but we need the index of nearest node. This checks every dot and finds its nearest neighbor. And if we plug this into a greater than compare, and for the top slot, we use the index node, which is just every single dot. So if we plug this into our selection, it should cut our vertices by half. And you might not have noticed, but it did remove some vertices. But I think we can delete even more. So I can just create a repeat area and plug in our geometry and route the delete geometry node through that. And then I can just repeat this about 2 or 3 times. And that should give us the amount of vertices we're looking for. I think repeating 4 times is too much, but 3 is about the sweet spot that we want to see. So next, let's work on the assembly effect. One tricky thing about this is it's kind of like a simulation in reverse order. So instead of all the particles just randomly flying out, we want to make sure they assemble. So to make sure they assemble at the end, we want to save their current position, and we can use that in the future. So let's, I always forget what it's called, capture attribute. I think it's this one, store named attribute, and we will call it particle position. And for the value, we can just use a position node. And now this stores the position of every particle in its current state. And now when we move it later, we can always come back to this by mixing in this attribute. Next, let's just hide all these for now, just so we can be focused on one area. And let's create a set position node. So right now we're going to be working on the beginning state of it, which is it being exploded. So I'm going to call this area here the initial burst. And I'm going to start adding nodes in here. Let's start with the particle position, and let's just add something to it. Let's plug it in. And we've got some movement. Let's see if we can offset them by the origin point of the object. So we're going to go get our group input node, and we're going to use the capture attribute node. And using this, we can tell it, hey, we explicitly want to reference the position of our geometry. And let's plug that in there. And if we add a scale vector and we plug that in, we've got the scaling up of our letter. So if we add a normalized vector in between, it kind of makes each particle's length from the center to the outside like the exact same. And the effect we get with that is a spherical explosion type of shape. So we're going to use that, and we're going to set scale to 4.8. But you'll notice if we stopped here and we only maybe animated this guy and we did something like that, it wouldn't really have the same effect as we see in our reference, because in our reference the dots are a lot more spread out and they assemble more slowly. So what we need to do is clear these keyframes and set it back up to there. We need to spread out all of these dots to make sure that there is some space between them. So we're going to reuse this index of nearest node, and we're going to basically say check the position of each index. So let me find position. Set this to vector because it's a position, and subtract it from its current position, then normalize it yet again and scale it again. So if we plug that in, you'll see that they kind of check their nearest neighbor and they go in the opposite direction. But the problem is it doesn't continuously check. So we can use another repeat area, and we can just set this to a low number, and we can just repeat this like 500 times or something like that. And if we slide this, you'll see that they start to spread out a lot more evenly. But we don't want them to spread out on the z-axis. So I'm going to just change out the scale node with a multiply vector and set this to 0.01 on the x and y axis, but 0 on the z axis. Now all our dots are evenly spread out, and we can tell them to kind of like return to their original position, and that's going to be our main animation. But before I go farther, this calculation will kind of just slow down our viewport and everything. So let's create a bake node, and we're just telling it, hey, you don't need to do this calculation like every time we add a new node, just make the calculation now. And if we make any more changes before now, we'll just have to rebake it, but that's totally fine. So first, let me select these nodes and put them in our nice little frame here. And I'm going to duplicate this frame, and the next part we're going to work on is reassembling these particles to their original position. So let's call this reassemble, and we need another set position node. So way back here we saved the position of each particle and we called it particle position. So now we're going to reference that. We're going to find named attribute, or we're going to call our particle position. Let's set that to vector because it is a vector. And we're going to subtract that from the particle's current position. Then we're going to do normalize and scale, and plug that in. So they are returning to their position, but then they continue going after. So we essentially need to cap their position once they reach where they need to go. So we're going to use a length node here, and then a minimum math node. And we're going to use that to drive the scale. Now, if you crank this up to, say, 10, you'll see that it forms a line here, and that's a mistake. And I think it's because we forgot to set our store named attribute to vector. And once we change that, we don't see a difference here, and that's because our baked node is baked. So let's just rebake it. And now we've got exactly what we are looking for. So if we keyframe this, then we get that slow assembly effect that we're looking for. Next, let's make it so we only see the particles once they reach a certain range. So we need a instance on points, and this helps us control, among other things, the scale, but we need an instance. So let's just use an icosphere and set the radius to 0.04. That's about the size we want, I think. And for the scale, let's use a gradient texture. Let's set our gradient texture to quadratic sphere. And we want to change the scale of our mask. So let's use a position node combined with a multiply node. And let's set the scale here to 0.3. And all of our dots are gone, but if we increase this, you'll see that they start to appear when they get close to our letter. So you can see this is basically where our gradient texture starts and ends, around this area. And if we want to increase that, we just bring that down. So let's try 0.2. And you'll see the ellipse gets bigger, 0.1, it gets even bigger. I'm going to keep it at 0.3 though. Now let's say we want kind of a sharper mask, so we don't necessarily want these super tiny dots. We want there to be less of a blur on that mask, so I'm going to use a color ramp node, and I'm going to plug that in, and then when I bring this close, you'll see our mask essentially gets sharper, so the dots that are farther away, they get larger. Now that's pretty much it. We just need to realize these instances, which tells Blender, hey, we want this to actually be geometry. And now that it actually is geometry, we can give it a material. So we'll give it a set material node, and let's call this, we'll just call it emission 1, and we'll set our emission to white and give it that. Now when we go into our render view, we have our white dots. So pretty much all that's left for the text effect is actually animating it. So before we animate it, let's clean things up just a little by duplicating our group input node, and let's bring it over here, and let's add a new input. We're going to call this assemble. So now we can change this value based on the text. So if I unhide the other text here, you can see that I can change the value based on the text. Now we don't necessarily want the center of our assembly to be the exact center of each object, so we can offset that a little bit over here in our initial burst. We can create an add vector. We have to temporarily delete our bake so we can see what this actually does, and that moves the origin point of our assembly. So I'm going to move it over a little bit, and actually what I'm going to do is create a new vector input and call this particle offset, and now I can change the center of the assembly for each object. Now let me bring this assemble unit up to 20, and I forgot about the heartbeat effect. So if you watch the reference video, you'll see that the P itself, it has like a heartbeat effect that's separate from the other letters. So we're going to add that in right now. It's essentially going to be an exact duplicate of this initial burst. So let's just copy that over and bring it here and set this to 0, and there we go. That's our heartbeat effect. I'm going to duplicate our group input node and set a new input, name it heartbeat. Now we can change this depending on each object, and I'm going to drag it up to the top because I feel like that would be a top unit thing right there. Also, if you watch the reference, you'll notice that these dots, they just passively jitter back and forth a little bit. So let's add that in real quick. So we're going to move over our endpoint. And guess what? We need yet another set position node. This one is going to be driven by a noise texture. And let's dampen that with a vector multiply. Let's leave the z-axis at 0, but bring these up to 0.5 or something like that. Set our dimension to 4D so we have the time, and when I slide this time, you'll see the dots jitter. And so I'm going to plug this into the frame and add a divide math node. And if I set the divide value to 300, that gives us about the jittering speed we want. Let me duplicate my frame here just for cleanliness, and we're going to select all these, move them into our frame, and I'm going to call this jitter. Now let me bring that closer and bring this closer. I'm going to unhide each object. If the objects are hidden for you, that's okay. We're going to bring them back. Just select each object and bake that repeat motion. So let's just go bake them all. Bake, 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 and bake. And now if we select all these, if we move the heartbeat, let's see, why isn't that working? Oh, it says node group's geometry input must be the first input. So I guess I dragged my heartbeat too high. So let me drag that down. And is that what the issue was? There we go. So you got to make sure the geometry input is the top input. I had the heartbeat above it. Now let me go and bake the others again. And now I can just go keyframe all these, but I'm going to wait to keyframe them. I'm going to set them to 10 each. So I'm going to select them all and set the assembly to 10, and then right click, copy to selected. If you notice a little bit of a bump in the center of each letter, that's because our heartbeat's default is set to 0.09. So we just got to go in there and set those to 0. The next thing to be done with the text is just animating it with these values, but I think it'll help us if we first tackle the wave effect. Let's name this Pluribus waves, and let's create a new object. It doesn't really matter what object we start with, but let's name it waves, give it its own geometry nodes, modifier, and we'll call it Pluribus waves. We're not going to be using the original geometry, we're going to make our own. We're going to make a grid, and for the grid, let's make it 18.6 by 10.6 meters, and let's distribute points on the faces. just like that. Set it to Poisson disk. Let's set the minimum distance to 0.3 and density to 50. So we have our particles. Now we just need to move them. So let's set the position. Let's start with a wave texture. We'll set the scale to 0.16 and set the type to rings, set the axis to Z, and you can already see some rings showing up. Let's change the center point of our rings with a position and add vector, and we can move this over here. And if we move our offset, we already pretty much have what we're looking for, but the only thing is that our particles, they move in a diagonal fashion, not really relative to our center point here. So to change that, let's combine this with a multiply vector. Multiply that with a normalize, which is connected to the new center point. And if we move the offset now, you'll see each particle is kind of moving relative to the new center. Now, generally it's best to keyframe the things that we want to keyframe. We make them group inputs. So I'm going to bring back our group input, and it automatically adds a input for me here called phase offset, and let's just call it wave speed. Now this is what we're going to keyframe to give us our waves, but you'll notice at the beginning of the video the waves are not present and they kind of just show up. So we need something that affects the scale of each dot that we can animate on, kind of like a mask. So just like with the text, we need our instance on point. For the instance, let's set this one to mesh circle and set the fill type to n-gon. Plug that in, set the radius to 0.04. And to keep it consistent, let's go back to our text and let's give this instance a sphere to set it to n-gon, set it to 0.04, and now they are all the exact same dot. Go back to your waves object. Let's add a object info node and connect it to a geometry proximity node. Now let's create a circle and set this to 128 vertices. Now let's fill the face and go to the object's visibility and let's turn off the camera ray visibility because it's just a mask. We don't want to directly see it. And let's change the display to bounds and go back to our waves and select the circle, but let's rename the circle to effector size. Let's use the distance into a map range. Can't fully remember if it's distance or position, but let's plug this in and let's remember to set our object info to relative, and it's working but in the opposite order. So let's click this and change our output to, we'll just flip the numbers on our output here, and now we've got our mask just like this. And so to have that mask, we just keyframe the scale of our effector size. And the next thing we need is a camera. So I'm just going to bring in my camera from my other scene, but this is just a normal camera with 50mm focal length. And the beginning position, let me hide the text geometry real quick. This is the beginning position if you want to copy that. And I've got it keyframed at 62, frame 62. and this is the end position that I have, which I might still adjust it a little bit, but this is what it's at right now. And in the beginning, let's change this window to 3D viewport temporarily. Let's set our starting keyframe on this guy. Give it a scale of this. And we're trying to match our reference video here. So the dots come on screen around this point, and they fill the whole screen by around here. So let me increase the scale of our mask to kind of match that. And it looks like that's about what we want. When our camera zooms all the way out, it's not filled all the way up. So let's just give it one more keyframe here. And let's animate our waves. Let's start at 0, go to frame 1, give it a keyframe, go to frame 30. Let's try -4.5 and set the keyframe. And if we select both of these keyframes, actually I'll just show you in the graph editor because it's easier to visualize. If we select both these keyframes and we hit Shift E on our keyboard, we can click linear extrapolation, and then we don't have to animate across the whole thing. It just continuously goes for us. And now if we play this back, we have that dynamic movement. Oh yeah, I forgot we have to add a material to our dots, so I'm going to do that next. It looks a little bit fast right now, so let me select our dots and move that in a little bit. And I think that's about right. Let me go back to geometry nodes. We need a new output. So I'm going to call it wave color and call it wave color. And now we need a emission node. Let's make it different from our text emission. So we'll just copy that material. And don't forget to set the material here, because even though the material is on our object here, our geometry nodes doesn't know what material we want to use. The material that's being set here is applied to our cube, but remember, we're not even using our cube. We deleted our cube and we created our own geometry nodes. So set the material and give it the emission to material. Now go to your shader editor and plug in an attribute node. And we're going to connect our wave color here. So just type in wave color. I think the reason this is black is because if we check our shader editor, we selected color attributes, but the attribute output in our geometry node editor, we set it to a float. And if our dots were any other color than white, we would want this to be, we can just set it to a color and then it should work. Now, since we still don't see our dots, I'm guessing I forgot to add a realize instances node, and this just tells it to actually create geometry. And there we see our white dots. And if I plug in our wave texture, then we even have the rings. But the problem is the offset is wrong, because in our reference, the peaks are the white areas and the valleys are the ones with the gray dots. Also, the valleys have a few dots that are white, but they're smaller. So I guess I will work on that as well. First, let's just copy our wave texture here, and I'm going to add a math node here. And this should help us change the offset. So let's do something something like that. And maybe I'll add a color ramp node, and I will decrease the size of the peaks. If we check out our reference, I think something like that is about right. Let's change our black area to be something like this. And we have to decide how we want to do these smaller dots, because we still have some gray dots. So maybe what we'll do is we'll just have two wave objects. So maybe we'll keep this wave one color, and for the valleys we will subtract the scale, and I think we would just do a multiplier in our scale probably. Let's see how this works. So just plug that in, and we probably have to adjust our black color to be something like that. Should be fine. Let's just go into our 3D viewport and let's duplicate this. Well, let's call it waves white, and then duplicate it and move it up a little, and we'll select the one that's under and we'll call it gray. And for this one, let's change the seed, but in order to not change the seed for each one, we need to use our group input node and create a new input. So this will be the seed, and then we'll go to our modifier and change the seed. Honestly, I might just make this its own geometry nodes, because I want to also change the scale of the valleys. So let's just duplicate this and call it gray and set these. So I have my gray waves object selected, and I created a new geometry node set up, and I'm just going to change that color to gray. For the gray dots, I took out the scale down effect, and let's decrease the density to maybe 10, and I'd say that looks about right. I feel like for the areas where there's peaks, I'm not really seeing the gray dots so much in the reference, so maybe we use this color ramp in the color output, and we just change the peaks to be black and change the valleys to be gray. And then if we adjust that, we have effectively removed the gray dots from the peaks. And that looks about right to me. Next, let's activate our geometry nodes for our text. Let's make sure our waves are originating from the center of the P. So let's move up. Let's hide the gray ones for a second, and let's move those up, and then let's just copy the exact same origin from the white to the gray. And we also need to change this origin up here, but we can just use it like this. I'm already kind of regretting making them their own geometry nodes instead of combining them somehow, but I'm just going to deal with it for now because I think we're pretty much done with it. So let's select our P object right here, and let's start keyframing this. So keyframe it at 0. I'm going to find a spot like right here where it looks like the particles are coming out of it, and maybe set this to 0.1 and then go forward a little bit and set it back to 0. Actually, let's duplicate that keyframe and give it a slight negative value. So now there should be a little bit of a follow through or bounce back, whatever we want to call it. And let's line it up to that burst. So let's line it up like it looks about right. Duplicate the end of the keyframe, and we're gonna highlight all these keyframes and press Shift E and click Make Cyclic. So if we look at the graph editor, this just makes a repeating pattern for us, and so we don't have to keyframe this over and over again. So we just have to make sure as it goes on it's still lined up with the burst. So let's drag the end to about here. Just keep playing with that end frame to change the length. I think that looks about right. Another thing you'll notice about our reference is they have kind of an additional mask around each letter. You'll see that there are no black dots. I mean, there's a few exceptions, but there's pretty much no black dots in close areas. So what we can do to replicate that is we can duplicate our geometry here, and I'm going to put it in a new collection. I'm going to call it text mask, and let me bring that up to the top. Now disable the other collections temporarily, and we can remove these collections. Actually, we can just combine it and be one object, and we'll just center the geometry just because. We don't really want there to be a mask around the P because we want the white dots being close to the P, and we want it to make it look like the particles are emanating out of the P. But I think for clarity, maybe we want the center of the P to have a mask. So let me try to select, let me see how easy it is to select this ring. Let me just go in here and select it by hand. Let me press F to fill that, and let me press P to separate the selection just to make it its own object for now, and I'm going to delete the rest of the P, and we might end up deleting the L as well, but we'll see. But I'm going to join these back together, and I don't think we need the text density to be so high, so I'm going to remesh it again to 0.04. And now it is a lower density, but it's going to be a little bit easier on our computer. And let me go back to the waves and select them. Let me hide the gray ones for now and go into our render view. So we need to change this white color with a object info, and we're going to use the text mask we just created. We're going to use a geometry proximity node, which is set to its faces, and the distance of each particle is going to be affected by a map range, and plug that into the color. And we're already getting it here, but let me increase the minimum to 0.3. I can hide the mask from view and enable our Pluribus geometry, and there we go. I'm also going to raise up our geometry slightly so they're not intersecting with our other dots. And let me see what it's all looking like here. We could add this mask into our gray dots as well. I think I'm going to leave it without the mask because I don't think it's too visually distracting. I guess the last thing is just animating each text assembly. Let's bring each one to 0, and let's start with our U because I think that's the first one that we see assembled. You can see in our reference right about here is when we see the dots from the U start to assemble. So let's hide our wave collection temporarily. Let's hide these other particles and select our U object. And let's bring this guy out to about here, I'd say. Let's move the particle offset over a little bit. I guess having the particle offset as an input is a little bit useless because we have to bake this to see the difference. But let me set it to 0.5 and then bake it again. Let me set the assembly to -2 right here, and basically finished right here. So we've got our U assembling. Maybe slightly slower. You'll notice in the reference the dots are smaller and they're more spaced out. So let me make a couple small tweaks to this node group. One reason we see these divide lines right here is because it's just enhancing our fingerprint, but we can mitigate that a little bit if we add in yet another offset position node. And just so you see what I'm working on here, I will bring the group output node here and show you what I'm working on. Let's exaggerate the fingerprint with a noise texture. Actually, let's just use a random value of 0.1 with 0 on the z-axis and -0.1. And this essentially destroys our fingerprint, but that's okay because we already saved the fingerprint position right here. And now we should see more of an evenly spaced pattern. So let me go back to this, and don't forget to rebake. And there we go. Our dots are more spaced out with each other. Anyways, let's scale down our dots until they reach more of the center. I think I should be able to do that just by adjusting this color ramp. Let me create a new handle and set this one to white and set this middle one more to gray, and I think that's pretty good. Maybe if I have two handles here and I copy the scale of this one, I think that's about good. Just in case you're curious, these values in the middle are 0.723. So now that we've animated the U, I don't think we really even need to animate the L. Let me just copy the keyframes from the U, select the R, hit I, and keyframe it, then paste those keyframes. And I'm just going to line up the animation with the reference video here. You'll notice the reference video has the assembly starting on the left. So again, I just need to go over to my particle offset, maybe try 0.5, and then bake it again. And then you'll see it starts assembling on the left. I'm going to try 0.65, bake it again, and that's pretty good, so I'll just leave it there. Now let me copy these keyframes and just keep going. Okay, I went in and keyframed each one. Now let me turn on the waves again, and let me just kind of scroll through. It's kind of hard to see the particles when scrubbing through because Eevee doesn't like fully render them, but for the most part I think it's looking pretty good, and I'll just render this out at the end to show you. I think the wave particles, even though they're black, they are showing up above our text. So let me go to 3D viewport here, and let me just raise this up even more. That should be good. Also, we don't really want the text mask in the beginning because we want to see those nice white peaks right here. So we need to make sure that we keyframe this text mask. So I'm going to use a mix color and set it to darken, and use the map range to darken the white value. Plug that in. So when this is set to 0, our mask doesn't show up at all, which is what we want in the beginning here. And when this is set to 1 is when our mask is fully there. So let's maybe have it at 0 right here, and just slowly keyframe it on to about here, and hopefully it's not terribly noticeable. Yeah, I think that should be good. The only other thing I'm noticing right now is the dots in the peaks. I want them to be larger than they are. So I've got the white waves selected, and yeah, I just had to change the offset a little bit more to about there. And yeah, that's really about it. You might just render this out real quick and adjust the movement keyframes more to your liking, more to fit the reference if you want. If you want to customize the text, you would just follow the same steps that we took with the SVG, but use your own text. So blah blah, we would do this, you know, center it. We would convert it to a mesh, and then separate each of these to be their own mesh, remesh them to have a higher density, and then you would just plop in the geometry node that we created right here straight onto that, and then you'd have to keyframe each one by one as well, and that would give you your custom text. Hope you enjoyed the video. Subscribe if you want to see more stuff like this. Thanks.